Awesome. So Ian, thanks for joining us. I think we may have a couple more dings as, latecomers join, but they're lost if they miss out on, some integral piece of wisdom that you drop in the first, 45 seconds or so. But super stoked to have you. I mean, I think that a lot of us in the club have been talking about kind of this intersection of interesting things you can do with LLMs and formal methods tools. And so it's fun when we can get people either from like purely academic backgrounds or more hacking kind of perspectives coming in to talk about this stuff. And there's also a lot of us, particularly Jacob, are interested in places where like puzzles and games can be used to explore hard scientific problems. I think there's some overlap there. So yeah, really, really happy to have you here, and thanks for coming to talk to us.
Yeah, thanks. Hopefully what I say will make some some sense. This is all just the product of like a weekend hacking a month ago or so. But um so I'm Ian Bicking. Hello. I work for Brilliant doing LLM based lesson development and enhancement, actually. So I'm very enthusiastic about about LLMs. And yeah, so the thing I came upon, I don't remember where I came upon it though. There was a paper recently um, that actually I found just after uh, I did this experiment, talking about like LLMs and whether they can solve this particular logic puzzle. And it came up a few different times as people were talking about like, can LLMs reason? Um, I found it a little strange of a question because like obviously they can reason because most responses that they give actually do require reasoning. You have to reason about pronouns and reason about all these sorts of things. But people have like this very high-minded idea of what reasoning means, which has to be formal mathematics, not informal. Um, I saw someone now. I wish I remembered the term someone used. They were comparing it to continental philosophical things and some of the English ones, and they had some good terms for like different kinds of reasoning. But I thought, okay, logical reasoning, and so this particular kind of thing came up. If you've seen this problem, maybe there'll be an example here. If not, I will look. So here's an example of the problem. This is where I pulled out some of these um, that you probably did in school at some point. You have this like setup where, in this case, like every drug was released on a certain date and does a certain treats a certain thing, and then you have a set of clues, and then you use those clues to determine how all these things match up. Uh, Now it's has if you hadn't ever done these and you sat down to one, I don't think you would actually be able to do one the first time around. That has a very specific language and it has a very like specific way of thinking about it. So often, for instance, they will talk about two entities, and that implies that they are two separate entities. And you have to like figure that out. So some of the normal logic stuff doesn't apply there. But so the kind of challenge was like, can you give this to an LLM and have it solve it? And for some simple ones, you can, especially if you kind of lead it through. Um, Though you can't always. I took this one, kind of copied and pasted it out here, and gave it to GPT-4o, had to go through these things. It went through a couple times and came up with, it did a bunch of thinking. I think it believed it. I tried to break it down rule by rule, which is another way to try to get it pace it a little bit so it doesn't overthink things. Um, and ultimately, it came up with two solutions, one of which I believe is the correct solution, one which is not. And then when asked to verify, it was able to verify that one was the correct and one was not, but um, not quite correct. And as you get more complicated, then it becomes much less likely that you will get a correct answer. So I want to see, okay, can we give the LLM the power to do logical reasoning uh, through an external tool? Um, this is something I've done a couple of different times. In some work for Brilliant, we've used Wolfram, the Wolfram language, for the same purpose to have the LLM write Wolfram expressions and then evaluate those expressions given the result of the evaluation. And now we have kind of a ground truth in mathematics in this case, in that case. And here, we have Here we're actually offloading like significant effort, where we're saying we're not just verifying something, but we're saying, oh, here, all you have to do is you have to figure out the logical rules, and this logical solver will be able to come up with a solution if you can accurately do that, which is not trivial. Um, so I'll show kind of the way I went about this. Here I just have like a parser again that comes up with all these things, normalizes them effectively so that everything becomes an identifier. Um, and then I have kind of a three-part solution. The first is a setup. Um, and here's the prompt, which we could look at more closely if we wanted to. This could actually be done programmatically because it's really like the way all these problems are set up is always identical. Um, so it's always, you have to declare the data types for each of them. You have to kind of figure out the associations, and then there's multiple associations, and then you have to like do all the transitive associations, right? So if Bisolam treats arthritis, and then the arthritis month has to be the same as the Bisolam month, right? Um, Someone else did one of these in Prolog, and I started trying to do it in Prolog as well, and then I got distracted before I actually successfully do it. It might be a better solution for this. I'm not sure. Um, these are all logical statements one way or the other. Um, and yeah, so if you go through here, this is a basic setup. I haven't even told it the rules at this point. And you can see here, if you execute this, so I'm using Z3, which has a Lisp-like language built into it for defining these rules. Oddly, the documentation seems to constantly push you towards using it programmatically instead of using the language. But because there's no program here, the LLM is writing the program, you actually do need a language. That's something I initially tried to do this with a SAT solver. I thought, oh, I'll just write it in whatever the SAT solver language is. And apparently there's none. I'd read about them and never tried them. And so they just have the like most craziest encoding that you have to redefine your problems in, and not helpful. So yeah, this we detect, we let it basically say as much as it wants to, and then just detect the Z3 inside of that. You don't want it to just create bare code. It is important to like give it space for thinking processes. I guess you could put it all in comments if you wanted to. And then there is a solution. This is one solution. Of course, there's like every solution at this point because we haven't applied any rules. And the solution is not unique. So this is the not unique program, I believe, which comes up with a different solution. So the to check if something is unique, you give it all the constraints, and then you come up with the solution, and then you say, what if that solution is not true? Is there another solution? And if there is, if it's solvable, even if you exclude the one solution, then it's not unique. So of course it's not unique once we defined it. At the second stage is actually trying to break down each of these rules into an expression. So in this case, well, this one's with Llama. I'll show a couple of different models here. I give it a specific set of questions that I wanted to answer about each one. These questions were written because I went through and saw the things it was incorrect about, right? So there's things that it had a particularly difficult time. And this is really actually true across several LLMs. And one way to deal with that is to not just instruct the LLM, but force the LLM to kind of tell you what you told it. And so these questions represent that process. So either or is one that was particularly complicated or particularly difficult, right? Especially GPT just like wants to believe that a logical or statement is the same as an English or statement, and it's almost never the case. It's an XOR statement. And then there's this little tricky part where if it talks about two different things, then those two different things have to be separate. And again, you have to like pay extra attention to that. So here are some of the rules that I came up with. It was proved 2 months after Bisolam. Obviously, this one's trivial because they're two different drugs, and so they aren't already not allowed to be the same. But um, and we just enumerate these things. I tried playing there. You can do mathematical statements in Z3, uh, but it made everything more complicated. And these really aren't like there's often differences and ranges, but it's really not like numbers in most of these puzzle problems. So here we see it go through this. Again, we find a solution, we find the negation of the solution, and then finally also ask it to rate itself, going through this one by one, checking each problem and seeing if it gets that correct, which it's generally quite competent at. So even if it doesn't get it right, it does understand that it got it wrong. So this is one of the simpler problems. I think over here, I took a more difficult problem. So you can see the setup. There's a lot more attributes. And then quite a few more rules. I'll just show the rules here. So this one, yeah, has several rules, and however this site rates it, these rules are considered challenging. So it's maybe it doesn't mean that it's as dense. Each rule is more essential to the solution, or there's some more sophisticated kinds of rules here. I'm not sure exactly how it rates that. And this one is definitely at the edge of ability. So in all of these, this one actually was correctly solved by Sonnet, Claude Sonnet 3.5, and was, I believe, not solved correctly by anything else. Right? So Gemini 1.5 was able to solve that previous problem that you saw. Actually, I'll go down to the solution one here. So Gemini 1.5 did not create a unique and solution. In fact, it might even have an erroneous solution. Yeah. At some point, also like there is like a sense of overwhelming, like the models become overwhelmed, and they start making mistakes that, like referring to variables that don't exist or things like that as you get larger things, which are like I don't know exactly how to think about those because those are not problems that um, you'll ever encounter in the smaller one. Like in a smaller problem, it may make mistakes, it may mistranslate a rule, but it won't just like forget about how the problem was defined. So there's a good chance that in something like that, there might be some opportunity to help the LLM focus or restate its variables or do something because it's like within its reasoning capability, it's just exhausted its working memory or something. Um, so Gemini wasn't successful. Claude was. O1 Mini was not, I believe, if we get down to the bottom of this. Yeah. And I should go back. So then the simpler ones, if you look at the simpler problem, GPT-4o, I believe, got it incorrect. I'm going to try to find the solution thing here. Okay. So in this one, the Llama got it correct. Gemini Flash, which is like their fast one, which I assumed would fail and did fail, got it wrong. Gemini 1.5, I believe, did get it right, and I believe O1 Mini did, but GPT-4o did. Okay. So O1, which is the newest model, is better, but is not as good as Claude 3.5 in this case. So that's fine, and as kind of an example of the, and if anybody has any questions or thoughts or anything, you are welcome to interrupt at any time. I don't mind.
Ian,
Uh,
did you ever encounter a scenario where it incorrectly thought it had solved the problem, where in other words, it misread the output of Z3?
um, I mean, okay, where I
Like,
thought I did actually encounter one, but I don't think. You mean so here where it's like verifying the rules and it says that it has this correct solution,
yeah,
but in fact, if we look at the Z3 output, it is not
yeah, yeah.
correct or maybe not unique. Um, I have not at this time encountered that, but that I do think that'll have some to do with how well you explain some of the rules to it, because it really does misunderstand rules at times, at which point it um, could do that. And if I'll try to make this bigger. Uh, just so I can zoom up. So this, for instance, is the prompt that actually comes up with those rules. And I both had to give it kind of these examples of typical ways rules are written, um, and then deal with some particular ones, right? So, right, this is one that tries to explain the distinctness of two things, right? So this implies that favalin is not the one that treats arthritis. If you don't specify that, that is a rule that will easily be overlooked. And actually, and now that I think about it, that is one of the ones that it would mark as correct if you didn't give it extra indications that that was in part of the rule. Right, so it would potentially come up with a solution where favalin treated arthritis and then would not do it as incorrect because it kind of gets mixed up at that point. Either is another one, and either and or is one where I had to force it to do that question and answering before I got reliable answers from any of the LLMs. Um, and then just teaching about a few different things. The implies operator, which still trying to decide why this is not an operator that anyone uses in a programming language, even though it makes sense. I mean, I guess implies is just what A implies B is the same as what not A or B, right? One of the, I guess it doesn't come up much, but um, so yeah, those are some of the cases where that would happen. I tried giving it, seeing like, so what advantage does Z3 really give? Um, if you give this simple problem to GPT-4o, it did get it incorrect. If I gave it to O1, the new model, it did get it correct. It does think a lot. 45 seconds of grinding away at this. But the harder problem that I gave there that Claude Sonnet was able to solve, O1 was not able to solve either using Z3 or on its own. In fact, it is still, yeah, it is still thinking theoretically. I gave it the problem just in this form. So in this form here, I'm just giving it the problem and asking it to solve it and relying on O1 to come up with its own thought process to define it. And we can look at some of this thought process, I believe. So here, 102 seconds of GPUs wildly grinding away. So yeah, it kind of like goes through these. I don't find these like particularly insightful to try to understand what's going on here. On the other hand, this output that you see, this the way O1 differs from the previous models is that it has an internal thought process that it goes through. And so it's kind of like chain of thought reasoning, but presumably more sophisticated than just saying, think about it step by step. On the other hand, it's like determining the reasoning on its own. It doesn't have any particular ideas about the techniques to solve this type of puzzle, except what it might have learned, which I don't know that it's like coming up with with that terribly well. But that internal thought process, I believe, actually does take the form of text, but they do not reveal that text to you. Instead, they then put that internal thought process through another thing, and then that gives you a baked text.
It's
So
also it's interesting just from a product perspective because the academics on this call might not know this, but they claim it's only 6 times more expensive than GPT-4, but that's actually not really true. It's misleading because they count all the tokens from the chain of thought. So my buddies at another small startup called MaiTai, they like were they had a thing where they asked every LLM to just return the numbers 1, 2, 3, 4 once every minute, and they were measuring how fast different LLMs were so that they could hot swap what they use for different tasks. And they ran up $100 an hour bill asking O1 to do this. So just 60 calls to O1 saying return 1, 2, 3, 4 was $100.
Yeah, if you like ask it a hard question, it's cool, and then you ask it an easy question, and it still thinks so hard about how to answer easy questions. Um, so in this case, it confidently said that it came up with a solution. It didn't. I asked it to check the solution, and it froze, I guess. It's aligning launch schedules forever. Um, so all the classic sci-fi premises where you can lock up the AI by giving it a hard enough or impossible question are for the moment true, perhaps. Um,
Are you actually running Z3 or just using the rule syntax?
this one runs Z3, so
Got it.
um, only verification. It doesn't really ever have a feedback loop outside of this like final solution checking.
Mhm.
But otherwise, yeah. Um,
And when a model fails to solve a problem, is it because it mistranslated the rules?
yes, almost always. Sometimes the initial, especially for large ones, the initial setup can be mistranslated, but because it could be done programmatically, it doesn't feel like it's. I don't feel like I should rate it on the initial setup. But yes, you can usually go through and find the rule that it mistranslated.
Got it.
Um, yeah, and I believe if it correctly translates every rule, I don't think there's any puzzle that could not be solved.
Yep.
Um, that's the promise of this kind of puzzle.
The only thing that might be hard would be well, maybe Z3 has a trick for this, but sometimes like solvers struggle with unconstrained problems. Like, Emmanuel's on this call. Emmanuel's father, Pete, teaches a theorem proving class where the students are asked to make a Sudoku solver with Z3. And one of the challenge problems is what's the hardest puzzle for the Sudoku solver? And the answer hilariously is the empty Sudoku. Like the empty board is like takes like an hour or something for the thing to solve. So that just intuitively, that's the only one I would think of. But Z3 might have some meta heuristic that it uses to bypass such a thing.
I mean, the initial setup is unconstrained, um,
And it
right?
just yeah,
And it always spits out a solution
yeah. Okay.
effectively instantaneously. Um, it's possible if I did actually use numbers, um, that things would fall apart. But yeah. Yeah, and the way I went about developing this prompt over here did involve going through this process several times, carefully reading the rules, figuring out where I made a bug, and then offering it corrections, or ways to think around that. And so I think that's kind of everything I have to show. Oh, I was going to briefly show Claude 3.5 when I gave it the easy question. It solved it correctly almost instantaneously. And when I gave it the hard question, it was not able to solve it. So Z3 served some purpose in that case. But yeah,
Awesome.
That's
Can I
super.
ask you a question?
Yeah, go for it.
Okay, so Ian, this was fantastic. Thank you for this presentation. And if you said you worked at Brilliant, right?
hmm
Okay, so this is really interesting to me because Brilliant seems to be, there's a lot of stuff on this site about how people can approach different problems and try to solve them, right? And then this is a technique that's a lot different than just implementing some search technique or like classic machine learning style algorithm. Why is this approach interesting to you? And why is this something that you chose to experiment over a weekend with? Like, this is a cool overview, but I'm curious, like, what sort of brought you to this? Does that make sense?
Yeah. So in general, I found like LLMs are quite good at translating, sometimes more than generating, right? So turning what is like thought of as this like complex reasoning thing into a translation problem seemed interesting, right? So can it translate logic? Can it understand somewhat open-ended questions and then translate it into formal logics that can be solved outside of the LLM itself was my goal there. Yeah.
Okay, cool. And that kind of reminds me of like a lot of times I remember in combinatorics class, all of it is like you learn a few key techniques, and then the rest of it is how can we reframe this problem into something we've seen before? Or in an artificial intelligence course I'm in, um, it's not the LLM based one, but it's like how can you make this look like a search algorithm? Just frame it as a graph, and then you can get a bunch of things. Is this like a similar thing you're looking at here? Like what maybe this is a hard to answer question, but yeah, like what is about this translation that's so interesting? Like, is this something that you see as like a side little curiosity that you've explored and now you're satisfied and you're going back to other things, or is it like more to unravel in this direction?
Um, I think there's a lot to unravel. I have a lot of different side things in this area, so I bounce between them. This weekend, I'm actually working on a LLM text adventure in a very different model. I did see someone wrote kind of an article about they were talking about search and LLMs, but when they meant search, they really meant searching a problem space, right? So like if you look at, I think the metaphor they used was the chess AI, where you can do a full neural net chess thing, you can do a full formal one, but the best ones currently do a combination of searching possibilities and then using, I think, a neural net to rate some of them, right? So you don't have to go quite as deep, but get some idea about what a good solution is. And it kind of like opened up this idea, but it's very hard to figure out what that exactly means in the much more open context of things you can do with an LLM, right? The search space of ideas or something, right? Like of
Yeah.
and in some sense, I mean, I guess you can think of the LLM as that very search space itself, right? It is doing an organic search of next tokens to a certain depth level to find the right solution, while also applying not just you know edge heuristics, but some other things of that. So and when I think of Z3 and what it's doing, to me, it feels again like a search, right? There's a search of all possible bindings, and you provide constraints, and then you can come up with solutions or sets of solutions or something. How to actually apply that, I don't know, but I think there's something there. What
Yeah,
exactly
yeah.
knows?
So it's not a question. I'll leave space for other
Yeah,
people to talk after this. But no, it's really reminding me of something interesting, which is um I think like when ChatGPT first came out, we kind of discovered that there was this entire class of problems of some just like human labor that wasn't that fun, that is now one that's tractable by a computer, right? Like I want to web scrape this page, I need to find this particular CSS selector. I can spend 20 minutes like clicking around and trying to send requests in Python that fail. Or I can like put it into an LLM and it'll give me a pretty good thing. But it feels like here, um, there's kind of another slice of this that's interesting, where a lot of times in um, a lot of times in math, you kind of get to certain scenarios where you can go down one path on a certain problem. Maybe if you like compute a bunch of stuff, you can eventually get your answer, or you can reframe it in a different way and the answer falls into place. And this is a sort of elegant solution that we like a lot of the time. And it feels like you're sort of getting at something like this, where with computers, it's typically really hard to encode, hey, maybe this shorter path to this different framing helps us get there. But like, I don't know. It's not like fully locked in my head, but it feels like you're hitting something here that I'm going to think about more after. But yeah, if I'm way off in the deep end, that's fine. We can change the topic. But curious if any of that resonates with
yeah.
you.
I I was just trying to get O1 to solve that problem and looking at what it was doing. And part of the thing that it was getting wrong is it was like it made kind of a solution, then it was like, oh, here's a problem. I'm going to go fix that. And then of course that, that's actually a terrible way to solve these problems, right? If you like write in a bunch of X's and be like, does this work? And then you like try to fix it, you never get there. And so part of what the Z3 thing does, and part of what a couple other prompt techniques that can do without that, is to like slow it down. So it doesn't try to jump to a solution, but instead tries to really understand the problem space in some way. Which just thought seemed like a metaphor for some of what you're saying as well.
Good
That's
question.
awesome. Thank you.
Sorry, Jacob. Question from Brennan, who says, curious to hear your thoughts on interesting open problems right now in machine learning, AI, and formal methods. And mentions that a lot of conversations have ended with kind of the observation that the ML or AI community seems to have a ton of people chasing a few ideas. I imagine Brennan, by context, is probably conversations with cryptographers who are saying this, if that context matters.
I mean, personally, I'm very focused on applications. I have never fine-tuned an LLM so far. Haven't done, which is like even the barest like minimum of getting in that direction. It's just there's so much possibility with applications of
No,
this
I
stuff that
totally get
yeah.
that. I guess what I'm wondering is, and again, this is over the course of a couple different conversations that I've had with various people. It feels to me like a lot of the mind share right now is maybe like, let's throw an LLM at this on the application side. I'm curious, let me phrase this a different way. What's like an application that you would really like to build uh, with an LLM or otherwise that you don't feel like you have the tools to do that right now with?
I'm also thinking some about the work that I'm doing at Brilliant. Often what we kind of do is we get a an idea and we put together some LLM stuff around it, and then we spend a lot of time then realizing like, oh, we didn't actually decide what we wanted, right? Like what is like the pedagogically best response, and how do you know what it is and stuff, which then turns into this uh, things that used to be embedded in training and hiring and other things around that, where you hopefully would like bring a human up to that understanding. It turns out, the AI can't do that either without some of that same process. And so, yeah, when I say application, like so much of it is understanding a problem well enough to figure out how to map it, potentially with a diversity of tools, right? So like using something like Z3, and there's all sorts of different things you could be putting in terms of like translating and understanding those results, which is very much like an engineering, I guess, answer, not a math answer. But yeah, that's where my head's at. I don't know. Do other people have thoughts?
I'd really like to know what happens if you allow one of the crappier models, like a small Gemini Flash model, to get the output from the bad Z3 run and interpret it and then try again. Like, you kind of build your own chain of thought, but with like the tool use in the middle. And, I don't know, if you give it a few steps, does it maybe succeed, or does it just get stuck going in some bad loop of coming up with bad models? I'd be curious about that.
I've generally had very bad luck with repair as a technique. So letting it do something, come up with the wrong answer, and then do it correctly, like doesn't work very often. And usually if you just figure out how to do it right the first time, like
Yeah.
a lot of what I think is happening with chat when people are interacting with it is that there's like a prompt design that's happening on the fly because you didn't really understand, and so you get something out, and then but if you knew everything at the end, you would just put it all into one prompt and it would work just as well. It's just that you didn't understand what you wanted to begin with. And And so, yeah, especially when engineering things, then those loops, I got to find that you will do better if you can take the failed things and then actually push that information into the initial prompt and try to get it right from the beginning.
And is that what you did to fix the either or versus logical XOR
Yeah.
problem? Makes sense. Yeah.
Yeah, combination of examples and forcing it through the question process.
Got it.
I've heard people talking about tree of thought recently, which I don't really know if there's a formal definition for any of these terms, but I guess like when you hear about O1, to me, it sounds like just a horrible version of gradient descent. Like, because it's like so ill-posed, right? But you're kind of, is the vibe correct of the direction it's heading in at each step? And it seems like you could maybe, instead of allowing the LLM to have all the prior prompt history or like conversational history, you have a new call each time, but you have some compressed representation of state that you use to decide kind of what move to make. And maybe there's something clever that can happen there. But I don't know about you, Ian, but I feel like a lot of times when I start thinking about trying to solve hard problems like this around like getting LLMs to do interesting things, I just end up reinventing like AI from the 80s and 70s, like expert systems and stuff like that. And I'm like, well, fuck, man, we already went through all this.
I mean, if you recursively apply it, you can get
Yeah.
some of that too. Like, if you're coming up with like a set of rules and you want to include the correct rules or something, but then you can also have an LLM take a set of rules and translate it to be appropriate for a different domain, right? So you might have a very generic set of ideas, and then you can have it, which could be distracting sometimes in the context of a specific problem, where you want it to focus on like, in case like a math problem, you want to like focus on pedagogy or something. You don't want to like get super focused on this, but by having those general rules and then phrasing them, it's almost like kind of a meta thought that you then get to refocus the LLM while bringing in that information. It can be interesting technique. Do other people have things with LLMs that they think they could wish that they could make, or like just take Brennan's question?
I do, but I'm just blanking right now. If you asked me like outside of this video call, I would have a lot of answers, but for some reason my mind is completely blank. But I hear you, Max, on the expert system thing. I definitely think that work was not wasteful. I think it's gonna experience a resurgence,
Totally.
spurred by LLMs.
Yeah, dynamic RAG or like or whatever hybrid RAG algorithms are it's just like expert systems with an LLM, right? So and
Yeah,
it's doing now.
I think this is such a promising direction. I'm glad you did this because I've had it in my mind to do this for quite a while. You could probably just like tinker if you can get the translation to work. And I think you could, if you could prepare this handbook, they could provide as context to an LLM. I think you could get the translation really good. And that would open up a lot of possibilities.
You could probably do some interesting things like having it come up with examples of true and false statements, given some rule or something, and then double check those against an individual rule to say like, does the Z3 rule that you came up with, does it actually satisfy, the basic heuristic that you might understand without all the implications? That could be.
Yeah.
Yeah, it's easy with puzzles. The puzzles like are so attractive because they're so like well defined, and like every time you get one of these zebra puzzles, there's exactly one solution and such, which of course is not the case for more interesting problems.
Yeah. I could definitely see this helping with like diagnosis. Like if you could also do some integration with like a BayesNet or something, just like a huge Bayesian network, and you just like extract a bunch of, things to input into the BayesNet that could help with diagnosis. That just came to mind.
And do you think that LLMs can be made better at reasoning if they have a hidden like formal model that they use and they call like a solver to reason over that model? Or do you think that it just kind of, oh, it's going to hallucinate crap when it like writes this model and then it'll compute the wrong, result and then make a wrong judgment call as a result. And so giving some like some tool use to like a model checker or something probably doesn't actually increase the ability of the LLM to on its own like solve generic reasoning puzzle. Like I guess how would you think about something like that?
I think it's a good example of grounding the LLM. In this case, grounding it in verifiable logic, right? Like it can hallucinate the output of the Z3, but Z3 is not going to hallucinate the output, right? So you get some of that. And again, you don't have to ask it to over answer a question in the same way, right? Like I didn't ask the model to ever actually try to solve the problem. Instead, I asked it to come up with the constraints for a problem. And I think sometimes when you jump, it'll always do what you ask it to do. Like that's one of the biggest bugs that I find, right? It's one thing we do is like, we have it like generate problems, and then we have like a set of criteria and ask it to critique the problems, and it will always critique the problems. Like it will always come up with something that's wrong with it because you said critique the problem, and it's like, of course, yes, master, I will find something wrong with this. You should consider more periods or all sorts of things, right? It's very creative about coming up with solutions. And one of the things it's going to do is if you ask it for like a solution to a logical problem, it will come up with the solution somehow. Like it'll just eventually just invent one. And so, having it holding it back from trying to complete.
Yeah, that makes sense.
That's part of like chain of thought too, right? It's like you can ask it to like come up with an answer, just boom, and it'll always do it, and it'll be wrong a lot of the time. But like you just have to kind of like hold it back and have it get there the long way. And yeah, to me, external tools are another way of having it do it the long way.
Sort of teaching people, the Claude Shannon, when he was a professor at MIT, would famously, a student would go to his office with this problem that they couldn't solve. And then what he would do with each student, it was often very the same thing, let's remove all these layers of complexity and just like to the simplest it could possibly be. Then you could solve it and then add the complexities back in one by one and extend the solution. So I think a lot of people actually also try to solve problems in one straight shot and they don't succeed. I have a lot of students and I often have to teach them that you have to define milestones, that will get you closer. So the LMs sort of lack that higher level reasoning. I think that could be provided by probably an external engine or something. Like what's an intermediate milestone that will get you closer to that goal?
I mean, so in some ways, like if you have a problem, you have a bunch of ideas about those, milestones as a more experienced person. Someone might be able to come up with them themselves. But there is also like this giant repository of people describing how they solved things, right? This is the LLM does get like a real picture into cognition because we describe our cognition a lot. Not always accurately.
Yeah, exactly.
Or good cognition.
When I write a proof in a paper, it's never the proof that I originally wrote, right? It's like the proof that like Pete helped me make that was concise, 3 weeks after I wrote some messy like 6,000 line proof. So yeah, we misrepresent our cognition, I think.
Yeah.
Well, someone's got to grab some more notes and scan them all and get the training set.
Yeah.
Less of these final papers and more of the which it does, but it does have a lot of access to a lot of intermediate work. And so, I mean, you could imagine that one question would be like, okay, the first thing an LLM should do is look at the problem, think about it, and look at it's like, how do people solve this problem, and then redescribe that, which is again another probably successful technique for a number of situations. But then does it have access to the right set of does it have access to like all those things? Has it seen examples that are appropriate? And how does it know to choose one? Of course, one of the nice things again is because it's a computer, you can have it choose 10 of them and try them all and see what you get at the other end, because it'll just go ahead and do it all. Which could also be really interesting. Like that could be another actually really good technique. Is like if you give it a hard problem, first have it brainstorm a set of possible approaches. You generally have to, if you ask it for a possible approach multiple times, it'll come up with more or less the same answer usually. But if you ask it to make a list, then you get much more variety. So ask it to make a list of them, ask it to expand each one of those ones, ask it to describe the steps in the abstract, maybe even like hiding some of the information that it's going to later use so that it can think more abstractly about it, and then use that as the, you know, thinking template. So I think of it as like, okay, now here is instructions on how to generally go through this problem, and here is a specific problem. Now try to approach it that way. Which maybe I just described O1. Like, I don't know. That's in theory, that's kind of what it's supposed to do, I guess. I don't know. I don't know if it steps back as much as that or not.
Yeah, that's so interesting. Yeah.
Ian, do you think we're ever going to see an LLM come out where, you know, the leap is as big in performance as, for example, Sonnet 3.5 was over, you know, any previous Anthropic model, or GPT-4o was over 3.5? Or have we?
I mean, 3.5 wasn't that long ago, so
Yeah,
O1 doesn't feel
I know. That's
actually
why.
like
Yeah,
a big leap over 3.5. I'm a little
yeah, exactly. So
disappointed.
it's still kind of depressing to me. Like,
Though
you know,
it feels like an immature direction.
yeah,
So it has the possibility that it is they got it so it's just a little bit better, which is
yeah.
often it seems how OpenAI releases things. It has to be a little bit better before they release it, and then they can keep making it better. But they until they make it a little bit better, they won't show anybody.
Yeah, and then they publish this paper about how it's better than PhDs at all these tasks. I'm like, dude, I can't even calculate a tip, you know, and so I don't know that that's all that impressive. If you cherry pick tasks that PhDs aren't good at, I mean, I don't know. I didn't read the paper that closely. Maybe the tasks are like really well defined, but it also seems weird. Like if unless you can come up with a new scientific discovery, you're not really better than a PhD at what a PhD is supposed to do.
It's just marketing. Most people don't know what a PhD is. They think
Right.
it's just taking more classes.
Yeah, exactly.
It's it does tackle some bigger problems. That's what I have found. Like for coding stuff, I can give it a big chunk of a problem, and it tends not to get as overwhelmed. But I haven't used it much. It's it's pretty new, so and it doesn't like it's expensive and super slow. So it also it's not like I don't like jump to it for the first thing. Um, but yeah, I mean Opus 3.5, who knows what that's gonna be like.
Are there other external engines you would consider inserting in place of Z3?
I looked at Prolog, but then got distracted. Z3 is really nice because it's so symmetric too. The input and the output is kind of the same. And it's all nice parsable expressions, S expressions. So it was pretty nice that way. And I looked at stat solvers. Yeah, they were so obtuse that I didn't didn't like them at all. Yeah, I assume there's other ones.
I think
Are lean and whatever.
solvers could be kind of cool. Ankit,
What's that?
I don't think Ankit's on the call today, but Ankit Kumar, yeah, he's a group member who made a really cool string solver for like these string algebra problems. It's kind of like solving for regular expressions, kind of. And you could probably do something fun with that. I don't remember how the algebra was defined well enough. Emmanuel might know, I'm not sure, but there's definitely like other types of solvers that kind of solve slightly different types of problems than stat solvers solve for SMT that, could be interesting.
That makes sense.
I think the most interesting would be come up with like actually really good relevant problems and not not silly puzzles. But if it feels like with a little bit of thought, you should be able to find real logical problems out in the world that are not programmatically defined, but again, that's where the LLM can turn a casually defined thing into something that's programmatically defined, and then see what you do with that, and potentially, turn that into experimental loops where, um, it proposes solutions to a problem that's not fully defined, but maybe can be you can then take the solution and then apply it and see, and then maybe learn more about it, right? Um, which is that's why I always like fast takeoff AI seems kind of silly because you can't just know things, right? Like if it's super AI is super smart, it means it could be super smart, but it's not super smart yet, right? Like it can't know more than what it's told until it has a chance to find out. Um, and finding out is just that loop of observing, hypothesis generation,
Mhm.
checking the hypothesis, which logic with logic stuff feels very relevant as well. Yeah,
I,
I don't
I've
know.
been, I don't know, Ian, if you've been following this stuff, but my friends and I have been talking a lot about like Harmonic and some of these other companies that are like Atlas Computing, people who are getting funds to try and do lean, theorem proving and lean with LLMs. And so, something that's like kind of interesting about that whole movement is it doesn't seem impossible to me that if LLMs ultimately are able to prove non-trivial theorems, which I think is a big if, they might write proofs that are just totally unexplainable and incredibly long. And so we might not really get more knowledge about the world despite having more facts about the world, right? That's like kind of an interesting possible outcome. I'm not saying it's the likely one or anything, but it does get to this, point about like they are just kind of weird little computational units doing things that don't necessarily reflect like human intelligence, right, per se.
Yeah, I mean, I guess you can think of like even like a partial program or something though as a building block that you can use, even if you can't understand, if the constraints are, if you feel confident about the constraints and they provide a meaningful output that can be simplified down to something. So I guess if yeah, it's the simplification that somehow makes them interesting, doesn't it? Right.
Yeah, I
If you
agree.
if you list out 1,000 equations and you say like these are true because they are the things you told me are true, or right? They're the input to the proof. You haven't like achieved anything outside of restating it. Um, but then is that good enough if your solver is good enough, right? Like,
I guess the point is, yeah, like if if you got a proof that was verified, in lean that indeed P equals NP, but the proof was just incredibly large. Let's say it's the equivalent of, all the books on Earth times a million or something.
Mm.
Then I would argue we haven't learned anything about the universe at the end of the day. This doesn't seem, it's no different from like God coming down and, telling you a fact, but you're like, well, I have no,
well, that would tell you there might be a way to translate it,
right.
right?
Yeah, exactly.
That there is God is out there.
Yeah.
He knows P equals NP,
Right.
and
I,
we
I
can
think that's
find him.
a I think that's actually a good start to actually have a proof that we don't understand. Then we can have AI like simplify it and explain it to us over time. So at least this is a starting point.
Yeah, that's fair. Cool. Well, Ian, thank you so much for talking to us. This is super,
Yeah,
super. Just to confirm, it's okay with you if I put the recording online for people who missed the event.
yeah, for sure.
Okay. And if people want to get in touch with you, or I think Jacob is kind of obsessed with games and might might play around with cave puzzles a little bit. If he has, if they have questions to send you, like, should they email you? What's the best way to get in touch?
Yeah, email me. I'm on Mastodon
Awesome.
more actively. I'm the only Ian Bicking, so if you find me, you found me.
Cool.
Sounds good. Cool.
All right.
Thank you so much, Ian. Really appreciate it.
That's incredible. Thanks so much, Ian.
Yeah,
Yeah, thanks a lot.
thanks.
Okay. Bye.